Q7125. The recommended entry to an airport traffic pattern is A. 45 degree to the base leg just below traffic pattern altitude. B. To enter 45 degree at the midpoint of the downwind leg at traffic pattern altitude. C. To cross directly over the airport at traffic pattern altitude and join the downwind leg. The correct answer is B. The recommended entry to an airport traffic pattern is to enter at a 45-degree angle at the midpoint of the downwind leg while maintaining the traffic pattern altitude. This entry procedure allows for safe integration into the existing traffic flow and minimizes the risk of conflicts with other aircraft. By entering at a 45-degree angle, pilots can position themselves in a manner that provides good visibility of the traffic pattern and allows for proper sequencing with other aircraft. Entering at the midpoint of the downwind leg ensures that pilots have a clear view of the runway and can effectively monitor the traffic ahead and behind them. It's important to adhere to the recommended entry procedure to maintain safe and orderly operations within the traffic pattern. Crossing directly over the airport at traffic pattern altitude and joining the downwind leg can create conflicts with departing or arriving traffic, leading to potential hazards. Similarly, entering at a 45-degree angle to the base leg just below traffic pattern altitude can disrupt the flow of traffic and increase the risk of conflicts with other aircraft. Therefore, the correct answer is to enter at a 45-degree angle at the midpoint of the downwind leg at traffic pattern altitude. This entry procedure promotes safety and efficient traffic management within the airport traffic pattern. 7135. How does the wake turbulence vortex circulate around each wingtip? A. Inward, upward, and around each tip. B. Inward. C. Outward, upward, and around each tip. The correct answer is C. The vortices circulate in an outward direction from each wingtip, meaning they move away from the aircraft's center line. As the vortices move away from the wingtip, they also exhibit an upward movement, gradually ascending into the surrounding airspace. Finally, the vortices complete their circulation by swirling around each wingtip, forming a rotating flow pattern. Understanding this circulation pattern is crucial for pilots and air traffic controllers to maintain safe separation between aircraft, especially during takeoff and landing. The wake turbulence generated by larger aircraft can pose a hazard to smaller aircraft following behind. By being aware of the outward, upward, and around circulation of wake vortices, pilots can adjust their flight paths and maintain an appropriate distance to minimize the risk of encountering turbulent wake disturbances. In summary, the wake turbulence vortex circulates outward, upward, and around each wingtip. This knowledge helps pilots and controllers take necessary precautions and maintain safe spacing between aircraft to mitigate the effects of wake turbulence. 7136. What effect would a crosswind of 5 knots or less have on the wingtip vortices generated by a large aircraft that had just taken off? A. A light crosswind would rapidly dissipate the strength of both vortices. B. The upwind vortex would tend to remain on the runway longer than the downwind vortex. C. Both vortices would move downwind at a greater rate than if the wind was directly down the landing runway. The correct answer is B. When an aircraft takes off, it generates powerful vortices of air called wingtip vortices. These vortices are formed at the wingtips due to the pressure difference between the upper and lower surfaces of the wings. The behavior of these vortices is influenced by the surrounding airflow, including the presence of crosswinds. In the given scenario, with a crosswind of 5 knots or less, the upwind vortex, the vortex on the side where the wind is coming from, would tend to linger over the runway for a longer duration compared to the downwind vortex, the vortex on the opposite side of the wind direction. The crosswind affects the movement and dissipation of the vortices asymmetrically. The reason behind this behavior is that the upwind vortex experiences the crosswind directly opposing its movement, which can cause it to stay in proximity to the runway and take longer to disperse. On the other hand, the downwind vortex benefits from the assistance of the crosswind, which helps it move away from the runway more efficiently. Understanding this effect is crucial for pilots and air traffic controllers to maintain safe separation between departing and arriving aircraft. Pilots of following aircraft must be aware of the possibility of encountering the upwind vortex when taking off in light crosswind conditions and take appropriate precautions to avoid its potentially turbulent effects. To summarize, when a large aircraft that has just taken off experiences a crosswind of 5 knots or less, the upwind vortex will tend to remain on the runway longer than the downwind vortex. This knowledge assists pilots and controllers in making informed decisions regarding aircraft spacing and ensuring safety during departures and arrivals. 7137. During a takeoff made behind a departing large jet airplane, the pilot can minimize the hazard of wingtip vortices by A. Remaining below the jet's flight path until able to turn clear of its wake. B. Extending the takeoff roll and not rotating until well beyond the jet's rotation point. C. Being airborne prior to reaching the jet's flight path until able to turn clear of its wake. The correct answer is C. When a large jet airplane takes off, it generates powerful vortices of air called wingtip vortices. These vortices can create hazards for other aircraft following behind, especially smaller ones. To minimize the risk associated with these vortices, it is essential for pilots to take appropriate actions during takeoff. The pilot ensures that they become airborne before reaching the flight path of the departing jet. Being airborne prior to reaching the jet's flight path allows the pilot's aircraft to climb above and away from the wake turbulence generated by the jet's wingtip vortices. Once safely airborne, the pilot can then maneuver the aircraft to turn clear of the jet's wake and avoid flying directly through it. This technique of becoming airborne and turning clear of the wake is an effective way to minimize the hazard of wingtip vortices during takeoff. It helps to maintain safe separation from the departing aircraft and reduces the risk of encountering turbulent wake disturbances that could affect the performance and stability of the following aircraft. To summarize, during a takeoff made behind a departing large jet airplane, pilots can minimize the hazard of wingtip vortices by being airborne prior to reaching the jet's flight path until able to turn clear of its wake. This procedure ensures safer separation and mitigates the potential effects of the departing aircraft's wake turbulence on the following aircraft. 7138. When landing behind a large jet aircraft, at which point on the runway should you plan to land? A. Beyond the jet's touchdown point. B. At least 1,000 feet beyond the jet's touchdown point. C. If any crosswind, land on the windward side of the runway and prior to the jet's touchdown point. The correct answer is A. When a large jet aircraft lands, it generates powerful vortices of air called wingtip vortices. These vortices can create hazards for other aircraft landing behind, particularly smaller ones. To maintain safe separation and minimize the risk associated with these vortices, it is crucial to plan the landing accordingly. You are ensuring that you plan to touch down beyond the jet's touchdown point. This means that you aim to land farther down the runway than where the jet has landed. By doing so, you reduce the likelihood of encountering the jet's wake turbulence, including the wingtip vortices. The vortices generated by the jet tend to descend and move outward from the runway center line. By landing beyond the jet's touchdown point, you allow more time for the vortices to dissipate and disperse before your aircraft reaches that area. This reduces the risk of encountering turbulent air and provides a safer landing environment. It is important to note that selecting an appropriate touchdown point also depends on other factors such as aircraft performance, runway length, wind conditions, and air traffic control instructions. Pilots should always adhere to the guidance provided by air traffic control and exercise good judgment to ensure a safe and effective landing. In summary, when landing behind a large jet aircraft, you should plan to land beyond the jet's touchdown point. This strategy allows for safer separation and minimizes the risk of encountering the jet's wingtip vortices during the landing phase.